Hello and welcome to revision classes on television. Today, we will be having a session in mathematics. Our guide is Abiodun Idowu and our topic today is circle geometry.
Now we are going to look at some questions involving circle geometry so that you'll be able to practice with these questions. Now the first question on the board, we are required to find angle PRS. So the first thing we do is to identify the angle PRS. This is angle PRS here. So this is the angle. I'll mark it out. This is the angle we are looking for. Now, I can say, let angle PRS be equal to y. So I'm going to put y in this particular position. And then I can also say, let angle SPR be x. SPR is this particular angle. So I'll label this place as x. Now we are ready for the solution. Have it in mind that what we are actually looking for is y. But to make the work easier, I've denoted that particular point here as x, where we are looking for y. So the first thing we'll do is to look at the theorems we have learnt before. Looking at this particular angle here, that is angle SQR, is going to be the same as x. The reason why SQR is x is because the two angles SPR and SQR are in the same segment. This and this are in the same segment, so they are equal. Examiners require you to write the reason. So what I'm going to do is to say SQR is going to be x. Reason for that, angles in the same segment. This is important. Examiners want you to do that. Now, after doing that, look at angle 40 and angle RPU or RPQ. That is this particular angle here. This angle here is equal to 40. They are both angles in the same segment. So I'll put that one down. RPQ is going to be 40 degrees. The same reason, angles in the same segment. Now at this point, I need to find the value of x by saying angle 74 plus x plus 40 is going to add up to 180 because they are the sum of angles on a straight line. So I'll go ahead to do that. 74 degrees plus x plus 40 degrees is 180. Sum of angles on a straight line. So from here, 74 plus 40 is going to be 114 plus x is going to be 180. So this implies that x is going to be 180 minus 114, and that implies that x is going to be 66 degrees. So these are our values here. X is 66. Looking at the diagram closely again, angle SRP is going to be the same as angle SQP. So this place will also be y. Then, because this angle and this angle, they are angles in the same segment. So I'm going to write that angle SQP. SQP is going to be the same as Y. The reason, angles in the same segment. So at this particular point, I can now find the value of Y, because angle Y, angle X, and angle 68 lie on a straight line. So I can now say angle Y plus angle X plus angle 68 all is 180 degrees. I'm going to write the reason. Sum of angles on a straight line, because this is a straight line. So angle Y plus angle X. Our angle X is 66, then plus 68. All is 180 degrees. That implies that angle Y plus 66 plus 68 is going to be 134. All is still 180 degrees. And when we collect like terms, Y is going to be 180 minus 134. And that implies that Y is going to be 46 degrees. This is all that is required for us to get the value of Y, which is angle PRS. Another factor is that as you are making progress, you must tell the examiners what you are doing. This is not the only way to this solution. Provided you are doing what is correct, you are meant to get the same result. Now, our next question is on the board. We are required to find angle WYZ. So we'll identify that angle in the diagram. This is angle WYZ. So that is what we are looking for. So to answer this question, we can say our solution will let WYZ to be the same as T. So I'm going to put T in place of WYZ. Then the next thing I'm going to do, I want to join X to M. That is construction. Construction. Join X to M. Doing that will make it easier for us to find the value of T. So I'll place my ruler and draw a line from X to M. Immediately I've done that, I can see a cyclic quadrilateral. This is a cyclic quadrilateral. And likewise, I can see an angle in a semicircle. This is an angle in a semicircle here. So in this case, angle WXM is going to be 90 because it's an angle in a semicircle. So I'm going to write that WXM is 90 degree. Reason, angle in a semicircle. So this place is 90 degrees. Looking at this angle, 90 degree, is an exterior angle to this cyclic quadrilateral. So that implies the opposite interior angle will also be 90 degrees. So this angle here will also be 90 degree because the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So at this point, I'm going to write the reason for this. That is angle Y, ZM is going to be 90. Reason, exterior angle of a cyclic collateral. So at this point, I'm going to consider this triangle and use the fact that the sum of angles in a triangle, 48 plus t plus 90, must be 180. So I'm going to say 48 degrees plus angle t that we are looking for, then plus 90 degrees, all is 180 degrees. Reason for that, sum of angles in a triangle. So I'm going to simplify this. 48 plus 90 is 138 plus t, all is 180. So that implies that t is going to be 180 degrees minus 138. And then that means t is going to be 180 minus 138 is going to be 42 degrees. So angle WYZ denoted by t is 42 degrees. You must endeavor to write the reason for every point you put down. Now we are moving on to the next question. The question on the board, we are given this particular diagram, and the question is for us to find the value of x. If you look at the diagram, you will see where x is. So this is the x here that we are looking for. When you look at this diagram also, you see parallel lines PQ and RS. So what should come to mind is the properties of parallel lines and a transversal. That these are parallel lines and these are transversal. That is your alternate angles, corresponding angles, and so on. Now in this case, if you look at angle x here and you look at the angle at this particular point, both of them are alternate angles. If this is x, this must also be x because they are alternate angle. You can see the pattern forming Z. That is some of the properties of parallel lines and transversal. Now, another thing, I'm just going to put this one down. That is angle OMN. OMN is going to be x. Reason, they are alternate angles. So we are done with that. Then another thing, when you look at the length OM and the length ON, both of them are radii. So I can say OM is the same as ON. They are radii. So that implies the triangle we have here is an isosceles triangle. And then an isosceles triangle, the base angles are always equal. So if this length is equal to this length, it shows we have an isosceles triangle. So if this particular base angle is x, this one too must be x. So I'm going to put that one down. ONM. ONM is going to be x. The reason for that, base angles of isosceles triangle. So at this point, we'll be able to find the value of x because x plus 140 is going to be 180 degrees, sum of angles on a straight line. So I'll write x plus 140 degrees is 180 degrees. sum of angles on a straight line. So x is going to be 180 minus 140, and that implies x is going to be 40 degrees. So we are done. We have gotten the value of x. Our next question now is on the board. We are required to find angle PTR and angle PRS. So the first thing we do, we identify PTR. This is PTR. So we are looking for this particular angle here. And then we are also looking for PRS. This is PRS, the whole of the angle here. Now, to start with, this particular angle, TRS, that is this point here, is subtended at the circumference by the arc TS. The one at the center is 76. That implies that angle TRS is going to be half of the one at the center, because of the theorem that says that the angle which an arc of a circle subtends at the center is twice the one it subtends at any point on the circumference. So what we are saying in essence is that angle T, solution, angle TOS is going to be 2 times angle TRS, 2 times angle TRS. Angle TOS is 76. That is equal to 2 times angle TRS. Then from here, angle TRS is going to be 76 divided by 2. And what we have is going to be 2 in 7 is 3, in 16 is 8. The reason why we have taken this decision here is because we are applying the theorem. And the theorem we are applying, I have to write it. Angle at center is twice the one at circumference. So, angle TRS is 38. So I'm going to put it in place. This is 38 degrees. We are done with that. Looking at what we have on the board, line TR is a diameter. Because line TR is a diameter, we should watch out for angle in a semicircle. So this angle here, that is angle TPR, is actually put on the circumference by the diameter. So it's going to be 90. So I'm going to write that down, that angle TPR is 90 degrees. Reason for that, angle in a semicircle. So this angle here is 90 degrees. Now at this point, looking at this particular angle here, that is angle PRT. Angle PRT and angle TQP, both of them are in the same segment. So this particular angle here will be 33 degrees. This and this are equal because they are put on the circumference by the arc PT. So I'm going to write that. That is angle PRT. PRT RT is going to be 33 degrees. Reason, angles in the same segment. So at this point, we can now find this particular angle here, that is angle PTR. Angle PTR plus angle 90 plus angle 33 is going to add up to give 180 degrees, because that is the sum of angles in a triangle. So I'll write it, angle PTR plus angle 90 degrees, then plus angle 33 degrees, all is 180 degrees. The reason for that, sum of angles in a triangle. So at this point, PTR is going to be plus 90 plus 33 is 123 degrees. All is 180. So at this point, we can now say PTR is 180 degrees minus 123 degrees. And that implies that PTR is going to be 180 minus 123 is 57 degrees. So we have answered one of our questions, PTR. Then PRS is combination of angle 33 and 38. So all we need to do is just to add the two of them together. So I can now say angle PRS is equal to 33 degrees plus 38 degrees. And that implies that angle PRS is going to be, when we do our addition, this is 1 and this is 7. We have 71 degrees. On this note, we have been able to answer this particular question. And I want to advise students, if you have questions on circle geometry, the first thing you do is to identify what the examiner wants you to find. After identifying what the examiners want you to find, the next thing you do is to figure out the circle geometry theorems you have learned in the diagram given. For this particular question, I was able to figure out that I have a diameter. You see that the line is passing through point O. And when I have a diameter, any angle on the circumference is going to be a right angle. I was also able to figure out the fact that we have angles in the same segment. If you look at this angle PQT and angle PRT, both of them are projected at the circumference by the arc PT. So they are meant to be equal because they are angles in the same segment. And likewise, we look at this diagram, you will see the angle which an arc of a circle subtends at the center being twice the one it subtends on any point on the circumference. If you look at angle 76, arc TS subtends it at the center. The same arc TS subtends this particular angle TRS at the circumference. Based on our theorem, 76 is going to be twice 38. That is actually why we have 38 here, because 38 is half of 76. So when you put all those things in place, the next thing you do is to ensure that whatever point you are stating as part of your solution, you write the reason. Like when I said angle TOS is 2 times TRS, I put the reason why I'm saying that in front of it, that angle at the center is twice the one at the circumference. Likewise, when I said TPR is 90, I put the reason that angle in a semicircle. If you follow all those points, I think you should be able to answer questions involving circle geometry. On this note, we have come to the end of today's lecture.
You can subscribe to NTA series on YouTube to watch or download past episodes of revision classes on television. That's the much we can take on the program today. Do join us next time for another educating session.